Hello friends, now we will talk about the next topic of operational amplifier, that is applications of amplifier, operational amplifier, that is waveform generators. This is again very important topic from different competitive examination point of view and from university examination point of view. You will find a lot of questions from this topic in different exams. In waveform generator circuit, we will be talking about square wave generator, pulse generator, triangular wave generator and spike or sawtooth wave generator. The first circuit here, I will be talking about square wave generator, which is also known as astable multivibrator. Square wave generator or astable multivibrator is basically a circuit which is basically we can call as the oscillator circuit, which is not giving you the sinusoidal oscillations, rather it is giving a square wave type of oscillation, right? So let us see the topic. This is the circuit. This is the circuit you have. It is the circuit which has two feedbacks, positive feedback through resistance R1 and R2, and I have negative feedback through this resistance and capacitor, that is RC circuit. So astable multivibrator or a square wave generator has two feedbacks, that is positive as well as negative feedback. So here in this circuit we assume something. Assume means what? We assume that output is initially to a saturated state, that is plus Vsat. That is my assumption I will be carrying. Why saturated? I will assume that this op-amp had some input offset voltage. Because of that input offset voltage, output gets saturated, right? So op-amp is non-ideal. Ideal in the sense it has infinite gain, but non-ideal in the sense it has some input offset voltage which is always there. So because of that input offset voltage, it has got the saturated output at initial stage itself, right? So initially we assume that output of the op-amp is plus Vsat in this circuit, in this astable circuit, right? So astable circuit is sometimes called free running oscillator. Why free running oscillator? Because it gives the consistent oscillation, square wave type of oscillations at the output. We will see how it happens, right? Now again we will be talking about two cases, case 1 and case 2. Output of this circuit will be either plus Vsat or minus Vsat depending upon the relative value of this reference voltage and voltage across the capacitor. When output is plus Vsat, V reference is positive. When output is minus Vsat, V reference is negative, right? So there are two reference values here, plus positive and negative reference voltages. So let us take case 1. So let us take case 1. In case 1, what we assume? Case 1, output is plus Vsat, right? And I have already given you the assumption. Assumption is what? Because of certain input offset voltage, I have output at saturated value because of infinite gain of this, and this circuit is having two feedbacks, positive as well as negative. Positive feedback gives the saturated output, right? So output of the circuit is plus Vsat initially. That is my assumption. It can be minus Vsat as well, because we don't know whether input offset voltage is positive or negative, depending upon whether voltage of this terminal is more or this terminal is more. So output can be either plus Vsat or minus Vsat initially, but assumption here is I am assuming the output voltage of the circuit is plus Vsat initially. So when output of voltage of the circuit is plus Vsat initially, let us see the sequence of events what will happen. The moment output voltage becomes plus Vsat, the reference voltage here will be R1 divided by R1 plus R2 multiplied by plus Vsat, and that is beta into plus Vsat. What is that beta? Beta is nothing but R1 by R1 plus R2, and that is called feedback factor, right? So this is your feedback factor. Fine. So reference voltage, the voltage at node B is nothing but voltage at node B is nothing but Vref, and that is equal to beta into plus Vset. That's the voltage I have. Fine. Now, what will happen to this part of the circuit? The moment this output voltage becomes Vset, the output voltage is Vset, the capacitor starts charging through resistance R through this path, a current starts flowing which is responsible for charging of the capacitor. So capacitor starts charging. You can please see the capacitor starts charging, right? Initially I have assumed the output voltage is plus Vset. The capacitor starts charging from 0 value because I have the plus Vset voltage at the output terminal, and that voltage at output is responsible for charging of this capacitor through this resistance in feedback path, right? Now, at certain instant of time, you can please see, at certain instant of time, the voltage across capacitor becomes more than this reference voltage. And what is reference voltage? When output is positive, the reference voltage here is beta into Vset positive value, right? So initially this is equal to plus Vset and this is plus beta into Vset, right? In the first cycle, in the first part of this cycle, right? So now at certain instant of time, the voltage at node A is nothing but capacitor voltage. So capacitor voltage becomes more than this voltage at node B, which is nothing but plus beta into Vset. The moment this voltage becomes more than this, initially when this voltage was less than this, voltage at non-inverting terminal is more than voltage at inverting terminal. So when voltage at non-inverting terminal is more than the voltage at inverting terminal, the differential input voltage of this op-amp, that is Vd, this is plus, this is minus. So Vd is positive. I repeat, when voltage at non-inverting terminal is more than the voltage at inverting terminal, Vd is positive and output of the op-amp will be plus Vset. So this is the portion of the curve. The voltage at inverting terminal is this, voltage at non-inverting terminal is this. So voltage at inverting terminal is this, which is less than voltage at non-inverting terminal. So for this portion up to this point, Vd is positive and output is plus Vset. But at this instant, what will happen? At this instant, voltage across capacitor is trying to become more. Voltage at across the capacitor is trying to become more than the voltage at node B. So that means your differential voltage will try to become negative, or we can say whenever voltage at inverting terminal is more than voltage at non-inverting terminal, differential voltage is negative and output will be minus Vset in this circuit. So from this instant onward, my output changes to minus Vset. I hope this is clear, right? And if nothing is there, what will be the level of charging? This will charge to plus Vset. Finally it will be level of plus Vset. That's what I am trying to say. Fine. Is it clear? Now let us proceed further. After this instant, my output voltage is minus Vset. So let us talk about case 2, right? Output voltage is minus Vset. When output voltage is minus Vset, Vref will become R1 by R1 plus R2 into minus Vset, that is output voltage. This is equal to minus beta into Vset, where beta you know, and you know what will be the voltage at node B? That is minus beta into V set, right? So voltage at node B changes from plus beta V set to minus beta V set after which instant? After this instant. That means reference voltage at node B changes from plus beta V set to minus beta V set at the moment when output changes from plus V set to minus V set. So output is changing from plus V set to minus V set at this instant, and reference is changing from plus beta V set to minus beta V set. Fine. So now what will happen? Instantaneously output has changed from plus beta V set to minus beta V set. But see it carefully. What is voltage across capacitor? Voltage across capacitor at this instant is nothing but this terminal positive, this negative, and that is beta into V set. So this is positive, this is negative, output is negative, so capacitor will start discharging. Capacitor voltage starts falling down. Why? Because this is positive, this is negative, so current starts flowing back and capacitor voltage starts reducing. So at certain point it becomes 0, so it comes here, and then it starts charging in negative direction with this and negative because output was negative, and it starts charging in negative direction. At certain point of time voltage across capacitor becomes again minus beta into V set. When it is negative at certain point of time, this terminal becomes negative and voltage reaches at this level, that is minus beta into V set. So when this voltage is minus beta into V set, what will happen? Your output changes from minus V set to plus V set. Why? Because when this voltage becomes more negative than this. Why? Because when output is minus V set, it's minus beta V set. So when it becomes more negative, voltage across capacitor try to becomes more negative means this side. When capacitor voltage try to becomes more negative than this, output suddenly changes from minus V set to plus V set. Why? Because when this is more negative than this, your differential input will become positive and output becomes plus V set, right? So output becomes plus V set. So when it is minus, it is positive, your output is changing from minus V set to plus V set, and it becomes plus V set. Fine. I hope concept is clear. Now again, since it has become positive, so it will first discharge and then charge to this value, that is plus beta into V set, and that instant is exactly similar to this. At this point your again output voltage changes from plus V set to minus V set. Fine. Now, and this keeps on your voltage across capacitor keeps on changing from charging between minus V set to minus beta V set to plus beta V set, and so on cyclically, and my output continuously varies from minus V set to plus V set to minus V set, and so on. Now see this part of the cycle waveform. So I have capacitor voltage varying from plus V set to plus beta V set to minus beta V set, then from minus beta V set to plus beta V set, and so on. So except this small part of the cycle, your cycle is like this, right? So it means at steady state operation, when it is continuously going on, at steady state my input will be changing from minus beta V set to plus beta V set, from plus beta V set to minus beta V set, minus beta V set to plus beta V set. So if you take steady state operation, I can draw this waveform from minus beta V set to plus beta V set. This is a steady state operation. Steady state operation means I am not considering very first cycle, I am considering continuous steady state operation, right? So this will be your waveform, right? And that is your analysis. Now you see it carefully. This part of the cycle is suppose t by 2, this part of the cycle is t by 2, this part of the cycle is t by 2, and so on. So this is t by 2. If you talk about this is t, this is 3t by 2, this is again 2t, and so on. So what is the period of this wave, square wave? The time period of the square wave is capital T, right? So sometimes I have to find the time period of the square wave, or maybe frequency of this wave, right? So let us talk about the time period of the output voltage of the circuit. Now you can see I have not applied any input to this circuit. This circuit is running continuously, giving me output continuously without any input, with some assumption that it was having some input offset voltage which gave me plus Vset initially, and that output voltage at saturated level is responsible for initiation of operation of the circuit and giving me the square wave continuously, because of which it is called free running oscillator, right? Now, so this circuit is free running oscillator. Sometimes there is a question, what is this circuit? This is a free running oscillator, right? Sometimes they give you the circuit and they ask the name simply in objective type ESE prelims exam, right? Now here I have output plus Vset, then it changes to minus Vset, it changes to plus Vset. So none of the stable is continuously remaining forever. My output is changing continuously. Because of that, we say none of the state of the output. First of all, how many states are there in the output? Either plus Vset or minus Vset. So it has got two states, but none of the state is remaining at one level. The state of the output is changing from minus Vset to plus Vset, plus Vset to minus Vset. Because of this, we call it as astable. None of the state is stable, because of which we call this as astable multivibrator, right? So multivibrator. Now I have to find the expression. I have to find the expression of the time period of this signal. So let us see how to find. For that, we need to have the knowledge of RC circuits in networks, right? So I'll give you the expression here. The variation of voltage across capacitor plays very important role, because that itself is responsible for changing of output from plus Vset to minus Vset, or from minus Vset to plus Vset. You must remember one expression. The expression of voltage across capacitor is given by Vc infinity minus Vc infinity minus Vc initial value into e raised to power minus t by tau. This is the expression of voltage across a capacitor in RC circuit. It may be having one capacitor or a number of resistances, or one capacitor and one resistance. In this case, which is that circuit? This is the circuit. This is that RC circuit. Fine. What is Vc infinity? Vc infinity is voltage across capacitor Vc at t equal to infinity. T equal to infinity means what? Here I am talking about this t equal to infinity, but we take only one cycle. If I leave this capacitor charging continuously through this resistance, what will be the final value? See this, finally it will reach to which level? To a level of plus Vset. So that value is infinity. Otherwise you won't be able to get any infinite voltage. It means if capacitor is continuously charging, the final maximum possible value of the voltage across capacitor is Vc at infinity. So initially if it gets continuously charged, and final value of the voltage across capacitor is this Vc infinity, and that is equal to plus Vset in this case, right? So that voltage across capacitor is plus Vset in this case if capacitor is continuously charging, and we will consider only first half cycle. right? Not first half cycle, but this cycle, which is at steady state, right? Now, what is VC0 minus? That is VC voltage across capacitor at t equal to 0 minus, right? So that means initial voltage across capacitor, and at steady state it was starting from 0 initially. In very first half cycle it was starting from 0 because it was not charged initially, but at steady state voltage across capacitor is changing from minus beta V set to plus beta V set, then from plus beta V set to minus beta V set. So initial voltage at steady state for this cycle will be minus beta into V set. So here it will be minus beta into V set. I hope concept is clear. What is this tau? Tau is called time constant of the circuit, and that for this circuit is given by R into C. That is time constant. I will explain you all these expressions in electrical circuits, and you can also see one video, that is time response of RC circuits by me on YouTube itself, right? I have already given you that expression in one of my video. You can simply type time, that is time response of RC circuit, right? Now, so what will be VCT here? VCT will be VC infinity is plus V set. So I write V set instead of writing plus V set, that is same thing, into V set minus beta into V set, but VC is minus, we have minus sign here, so instead of writing minus I can write minus beta V set, right? You can write it like this, multiplied by e raised to power minus t by RC, or you can write like this, VCT is equal to V set minus that is V set can be taken outside, 1 plus beta into e raised to power minus t by RC. Fine, right? But interestingly, at this was t equal to 0, at t equal to t by 2, at t equal to t by 2, this is at t equal to t by 2. What is the voltage across capacitor? That is this. So at t equal to capital T by 2, voltage across capacitor VC is nothing but plus beta into V set. I repeat, if it was charging continuously, what will be the final voltage? Plus V set, but and it was starting from here, but at t equal to t by 2, at this instant, what is voltage across capacitor? That is plus beta into V set. So at t equal to t by 2, VC t by 2 is what? Beta into V set. So this gives, so replace t by 2 here and VCT by this. So this gives beta V set is equal to V set 1 minus 1 plus beta into e raised to power t by 2 RC with minus sign outside like this. What I have done, I have taken V set as common. So this and this gets cancelled out. So this gives 1 plus beta into e raised to power minus t by 2 RC, that is equal to 1 plus beta, right? So I can simplify, this gives, or this gives what? Time period of the signal. That is, I can write it directly here. This is 1 minus beta, not 1 plus beta. When you take beta on this side, this will be 1 minus beta. So this gives what? You can see it carefully. I have t equal to, that will be what? That will be 2 RC. This will be 2 RC, or you can write like this, e raised to power t by 2, or I can write t equal to 2 RC natural log ln 1 plus beta by 1 minus beta, 1 plus beta by 1 minus beta. This is the expression of time period of this circuit, which is very important from examination point of view. You will have a lot of questions. There can be many questions based on this expression, that is 2 RC ln 1 plus beta upon 1 minus beta, where beta is what? Feedback factor, that is R1 by R1 plus R2, right? So that finishes your astable multivibrator. In next video we will be talking about monostable multivibrator, but there can be questions based on this expression. You may be given this circuit and they may be asking you the time period or frequency of the square wave, right? So just remember this topic, this is important. We will see the example based on this circuit first, and then we will start with the next topic. But before that, let us see the examples based on astable multivibrator. Now let us see the example based on the square wave generator. So this is the square wave generator circuit here. The circuit shown in the figure of a waveform generator. Circuit shown in the figure is that of a waveform generator. Assuming ideal devices and plus minus 12 volt supply, the output V naught is R. Remember, I have positive feedback, I have R and C on the negative feedback. This is which circuit? This is a square wave generator. So but remember, when you connect zener diodes at the output of the circuit, that limits your voltage at breakdown voltage of diode plus forward voltage of diode, but zener diodes are consumed to be ideal. So voltage at output is breakdown voltage, either plus 6 volt or minus 6 volt. So your output will be a square wave. Output will be a square wave with amplitude of what? Plus minus 6 volt. Now the question comes time period of the signal. So either option B or C are the answer. The time period of the square wave generator is given by T equal to RC ln 1 plus beta by 1 minus beta. I hope you remember that. Beta is nothing but that is R1 by R1 plus R2, where R1 is this resistance, R2 is this resistance. So that is 10 by 10 plus 10, so that is 1 by 2. So T will be equal to, R is given to you, this is R, this is C, if you remember the circuit. So this is 10 kilo ohm, that is 10 is power 3 into 1 microfarad, so 1 into 10 is power minus 6 into ln of how much? That is 3 there. So you are able to calculate the value of the period. This is given here, and that comes out to be 21.97 microseconds. So that is the example which appeared on a square wave generator.